Hello, dear students. So, today's lecture is about Dirac Delta functions. You might have come across these Dirac Delta functions. It has wide applications in different branches of physics or in different fields. You can say that. But so this how we can define this Dirac Delta function. So it has some particular property. Like if you talk about that, so it is property that this we are defining this Dirac Delta function by delta of that x minus a. So it can have infinite and it can have maximum value if x equal to a, and if it will be and x is not equal to a, it will be equal to 0. So that means at the origin, because we are saying that here x equal to a 0 at the origin of this what. So at x equal to a 0, it has maximum value. So that is basically it has maximum value at that point. And if you go towards it as left or right, so that means we have different points like a1, a2, a3, or towards the left side a5, a6, a7, right? So there our x is not equal to a0 because we have different values of a's there, right? So in that case, the value of the function will be 0. So that if we have some functions which basically satisfies this property, it has maximum value at the center, and if you shift, so if you go towards the left or towards right, so its value will be 0. So such kind of functions are called Dirac delta functions. Or if you talk about like plane wave, we have some e raised power I 2 pi I xp, so that behaves like a Dirac delta function, right? Or if you talk about the orthonormal functions, if you have two functions, if you talk about the quantum mechanics, if two functions are orthonormal, which are orthogonal as well as normalized, so those orthonormal functions are also behave like Dirac delta functions. So in nutshell, I can say that. So we are defining Dirac delta function by this way. It should satisfy these two properties, right? So if we talk about this, if we have a point mass here, so this is point mass. अगर मैं यहाँ पे एक point mass consider करूँगा, so its density will be infinite at the center. So the density of this point mass, it will be infinite at the center. So if you go towards the left or towards the right side of this point mass, so its value is 0 because the density at that point will be 0. So this is the example. So how we can define these Dirac delta functions. So that means Dirac delta functions satisfy these two conditions. And so today's topic is about we have already discussed what's basically Dirac delta functions, how these plane waves are, if you talk about those orthonormal functions, how they behave like Dirac delta functions. And it has wide application. If you talk about this position momentum relation, you can also use that this Dirac delta function in order to interpret, like if we have for a fixed value of position, you can have different momentas, or you can take the reverse of that. That means for a fixed value of momentum, you can have different positions of the particle, right? So this is what basically our uncertainty principle tells us, right? So it has wide application, I can say that. But our today's topic is about to discuss the different properties of these Dirac delta function, right? So first property is that our this integral from minus infinity to plus infinity d of x delta x d of x will be equal to 1. So when we integrate something, we're basically calculating the area under that. We're basically calculating the total area under that curve, right? So that means the area under that curve will be equal to 1. So that means we can have a function. This function will be like this, right? So that means the area under this curve. So this will be equal to 1, right? So this is the first property, that limit goes from minus infinity to plus infinity. Delta x d of x will be equal to 1. So instead of that, अगर हम for example कोई भी function लेंगे, if we have some square wave functions like this one, or you can take triangular wave, or you take that sinusoidal wave, कोई भी wave ले सकते हैं. But provided the condition should be, if we say that this is x equal to, if the height of this square wave is 2l, right? So this should be, the width of this should be equal to then 1 by 2, right? Because the product of this with this, the product of this height and width, it should be equal to 1. Like if we have this, if this is equal to if the height of this peak is some L, so this will be equal to then 1 by L, right? So that means overall the product of this width and the height, it should be equal to 1. So then those functions behave like Dirac delta functions. So that means every function behave like Dirac delta functions, provided that limit that function it goes to 0, right? Or you can say that this limit, this L goes to infinity. So in that case, our function, so the area under that curve will be equal to 1. So this is the first property, that limit minus infinity to plus infinity, delta of x d of x equal to 1. Okay. So this is first property. Now second property. So second property is that the integral from that minus infinity to plus infinity, that f of x delta of x minus a equal to f of a. Let's prove it. So we can write this as, so we know that if I write that f of x delta of that x minus a, so that will be equal to, because if you consider that अगर हम फर्स्ट प्रॉपर्टी यूज करेंगे डायराक डेल्टा फंक्शन की, तो वो कह रहा है कि अगर x a होगा, if x equal to a, it has maximum value, the function have maximum value, so that means when x equal to a, so it will be f of a, right? Because at x equal to a, right? So what should be the, if we integrate this equation now, so if we integrate this equation, so we can write this as, so what should be its value now? Because using that property, तो अगर हम फर्स्ट प्रॉपर्टी यूज करेंगे, that limit that minus infinity to plus infinity delta x dx equal to 0, because at x equal to 0 it has maximum value, that's equal to 1. So area under that curve will be equal to 1. So using this property, so because our x equal to a here, because I am putting that when x equal to a, so f of x will be equal to f of a, so it is f of a, and this integral, so this will be equal to 1 then. So that means this will be equal to that f of a into 1. So that's equal to f of. So this was the second property, that integral from minus infinity to plus infinity f of x delta of x minus a. So that should be equal to f of a. And that's basically what we get here, that's f of a. So this is the second property of this delta function. And now the third property. So the third property is that if you take the limit now, so it's not necessary you take that limits from minus infinity to plus infinity. If you have limit from a to b, right? And you define this f of x delta of x minus c d of x, that's equal to f of c. So it is equal to f of c, but that c, because I am saying that x equal to c, so it is equal to c only if x c belongs to a and b. So that means that c, that I will give one example. So that if this c belongs to this limit, between these limits, then we can say that it has some value, that f of a. Or instead of that, if that c doesn't belong to that interval between those limits, if that c doesn't lie in between those two limits a and b, so in that case the value of this integral, that minus infinity to plus infinity f of x delta x minus c d of x, that will be equal to 0 in that case. So I will give one example. If we take now, for example, we have this from 1 to 2 f of, or you take that okay, delta of that x minus, or you write, okay. So suppose we have this integral, okay. तो अगर इस इंटीग्रल को मुझे सॉल्व करना होगा, so first of all it should satisfy these two conditions, it should satisfy one of the conditions, then accordingly we can write the final value of this integral, right? So first our limit जो हमारा है, that's 1 to 2 x square plus 2 into delta of x minus 3. So in that case our x equal to 3, so that means our x equal to 3, but it doesn't belong to that a and 1 and 2, because our limits are from 1 to 2. So that means the value of this integral will be equal to 0, right? Or instead of that, if we have some 1 to 3 x square plus 2 delta of x minus, so it has some value, because now our c is here 2. बट दैट सी, जो हमारा सी है वो यहाँ पे लाई होता है इन बिटवीन दोस लिमिट्स 1 and 3. सो दैट मीन जो इसका वैल्यू होगा, तो इंस्टेड ऑफ दैट, because it is value equal to, that is f of c, but c is our 2, because x equal to 2, it has maximum value at that point. So that means this will be equal to that x square. So instead of that x square, we can write this as, that is 2 square plus 2, right? So that means I can write its value, right? So its value will be 2 square plus 1, so it is 6, right? And this will be equal to 1. Okay? So that means, so this is another property that अगर हम यहाँ पे define करेंगे कोई point, so that point like C, it should lie between those two limits. अगर वो इन दो लिमिट्स में lie करता है, if it lies in between those two limits, then we can say that it has some value, that's f of C. If it doesn't lie between those two limits, its value will be 0. So this is third property of these delta functions, right? And one more property is, that is, if we consider now the product of these deltas, so delta of x minus a into delta of x minus b, product of these deltas to d of x, and we need to calculate what will be the area under that curve. So because we are integrating it from minus infinity to plus infinity, so that is equal to delta of a minus b. So we need to prove it. Okay, so that means we have two delta functions. Okay, okay, so okay, let's write now. So taking that left hand side, LHS, so that is, okay. So this is equal to, so let us put now, let uh, x minus b, okay, you choose that x minus b. Okay, so we are doing some substitution here, that is x minus b equal to y, or x equal to b plus y. So limits remain the same, because limits are going from minus infinity to plus infinity, so it doesn't matter. So limit is, they remain as unaffected, right? Okay, so we can rewrite its value as, so it will be equal to, so instead of x, you need to write that, okay, so instead of x, we write that b plus y minus a into, sorry, what I wrote here, so it should be here, let me write it. Okay, so that's equal to delta of minus, okay, so what I did here, so x minus b, so this is a minus x, sorry, so okay, so let me write here, better is to write this way. Okay, so let me write here b minus x, that's correct. Okay, so okay, so there was some mistake. Okay, so this is a minus x, and this a minus x. Okay, so this will be a minus b minus y. Okay, and this will be delta of y, and dx will be equal to 0, because I am doing that substitution, that x minus b equal to y, and then instead of x के बदले में लिखूंगा b plus y, and you will get this value. Huh? Now, so what does this indicate? Because if I put that, so I can rewrite this as, so this will be equal to that minus infinity to plus infinity delta of that a minus b minus y delta of y minus 0 t. Okay, So at y equal to 0, so at y equal to 0, so this will be equal to, so let us consider, so this is some function, okay, so this is some f of x. So at y equal to 0, at y equal to 0, so what will be its value? So this value, its value will be equal to, so इसका जो value आएगा, so it will be that delta of that a minus b, because y equal to 0 and inside will be that minus into plus infinity delta of y dy. So that's equal to delta of a minus b, right? Because यहाँ पे मैंने क्या किया, I put that y equal to 0, right? Then when you put y equal to 0, so ये बन जाएगा delta of a minus b, because the function of y here, so you can take it outside the integral and the value of this integral. So using the property of that, first property of that Dirac Delta function, तो इसका value 1 आ जाएगा. When you calculate area under that curve, it is equal to 1. So this should be equal to delta of a minus b. Okay. So this is another property of that Dirac Delta function. And one more property, that is about, if you calculate now what is delta of kx, so that's equal to 1 by mod of k delta of x. So that means I'm taking the absolute value of k, so I can take both the cases, either k can be positive, so first case I consider that k is positive, and in second case I consider k equal to negative, then I can generalize it. Huh? So first is that, so before that, okay, so this one, okay, so before that, okay, so what I did here, okay, so this I can generalize, so this I can generalize, so this is equal to, okay, I can generalize this as, so I can generalize this as, I can write this as limit from minus L to plus L, delta of a minus x. So that's equal to delta of a minus b, or it is equal to 0, right? So first is that if that a is that greater than minus L and b is less than, and second case it will be 0 otherwise. Because जो हमारा पहला था, we basically take the limit from minus infinity to plus infinity, delta of a minus x, delta of b minus x minus b, d of x. So that was delta of a minus x. Now if you choose some limit from minus L to plus L, so it is values again that delta of a minus b, provided the condition is that जो हमारा a है, it should be greater than minus L and that b should be less than L. So it should lie within those limits, minus L to plus L. So then its value will be delta of a minus b. If it goes outside, so if a will be less than minus L, so that means अगर हम left side जाएंगे, so suppose we have this delta function from minus L to plus L. So I am saying this function. तो यहाँ पे हमारे function लाई करनी है. तो यहाँ पे हमारा maximum value है, that is basically delta of a minus b. Okay. तो अगर हम इस साइड जाएंगे, so that means यहाँ पे जो value हमारा है, वो that will be less than minus L here, or here it will be that b will be that greater than L, right? तो यहाँ पे b is greater than L, तो वो ये वाला region आएगा, or if you consider this one, so in those cases our the value of this integral will be 0. So that means it should lie between these limits from minus L to plus L. Okay. So now the another property is that if you consider now another, that is delta of kx. So k is some positive value, right? So that's equal to 1 by mod of k delta of kx, right? So first let's write now. We know that this limit from minus infinity to plus infinity, that is f of x delta of x dx. So we consider some f of x is some arbitrary function and multiply it to this delta function and calculate its area under that, huh? And d of x. So first case is that अगर मैं यहाँ पे लूँगा if k is positive, तो अगर मैं k का वैल्यू क्या लूँगा, if k is positive, right? So k can be plus 1 plus 2. In second case, because I am taking that mod of that, that means k can be positive as well as negative. So first case is that if k is positive. So let us do one thing. So let us consider that kx equal to y. Okay. So let's use it here. So this will be equal to okay, because जो हमारा x है तो it is because it was f of x, so x हमारा है that's y by k. So using that substitute kx equal to y, and then delta of kx, so kx equal to y, that is delta of y, and d of x is dy by k, right? Now you can okay, you can rewrite this as, so this will be equal to that 1 upon k minus infinity plus infinity. Okay, is it okay? So that means if you put y equal to 0 here, so putting y equal to 0, if you put that y equal to 0, right? So that means our value will be equal to 1 by k, that f of 0. Okay, because y equal to 0, so this is f of 0, right? And delta y. Okay, so because this its value, because it is area under that curve, delta y dy, so first property of delta function, so it is equal to 1. So इसका value 1 बन जाएगा. So that means I can have that 1 by k f of 0. Okay, or you can write this as, so this will be equal to that 1 by k, or you can write this as f of 0 as that's limit from minus infinity plus infinity. Okay, and inside will be, so that will be equal to f of y f of y, sorry, so I need to write here delta y also, delta y. You can write this as, so because you can, instead of that you can write this as 1 by k plus infinity, you can write this as f of x delta of x dx, right? Or if you compare this with this equation, because we have this limit from minus infinity plus infinity, that is f of x delta of kx dx, right? So that means from here the delta kx is equal to 1 by k delta of x. Okay, so this is what we do. Okay, so I can do some problems on this also. So maybe in our coming lecture in classwork I can show you some problems. Now instead of that, if k is negative, if k is negative, so using the same procedure, तो हम again वहाँ पे जो हमारा integral होगा, so that will be equal to, we can have this integral here, that limit from minus infinity plus infinity f of x minus kx dx, so that's equal to minus 1 by k delta, right? So we'll get this thing. Okay, so that means I can generalize this as, I can write this as that limit from minus infinity plus infinity, that okay. So this is another property of delta. So because I am taking both, तो यहाँ पे हम substitute करेंगे that our minus kx equal to y. So again using that same procedure, तो यहाँ पे सेम प्रोसीजर में यूज करूंगा, तो यहाँ पे बस क्या बन जाएगा, दिस विल बी -1/k, then f of that f of -y, delta of -y dy, right? So you will finally get that -1/k into delta of x, right? So that means I can generalize this as that 1 by mod of k, so it depends upon the value of k, either it can be positive or it can be negative, right? So in both the cases you will get that 1 by k and delta of x multiplied by delta of. Now there is one more property, that is basically if you take that, so okay, so where is that? Okay, so there, okay, this. Now another property is that our delta function is an even function. So that means if you shift that x to minus x, so delta function means same, right? So there is no change, right? So it's an even function. So delta function is an even function. So that means our delta function is an okay. So let us. So we need to check that this delta of minus x equal to delta x, right? So let us use earlier property. So that means so we know that our delta of kx is equal to, that's 1 by k. Okay. So if I use this property, this mod of k, okay, you write mod of k. Now, if you put that k equal to -1, so what is delta of that kx? That's minus of x, because k हमारा -1 है. That's 1 by that mod and delta of x. So delta of minus x equal to, that's equal to delta. Okay. So that means it's an even function, because we are taking the mod of this, that's -1, so it's +1. Take only magnitude, and that will be delta of minus x will be delta of. And one more property is that if you take now the derivative, if you take the d by dx of delta x, so that means you are taking the derivative of this. So we are getting that delta d by dx of that delta of minus x is minus delta of x, right? Okay, because already this is an even function, but when you take the derivative, so you can have sign outside, minus d delta of x. So how we can prove this? So that means okay, so let us rewrite this term. We know that we know that delta of minus x equal to delta of x. So because delta x is an this delta function is an even function, so delta of minus x equal to delta x. It's an even function. So let us differentiate it both sides. Okay. So if I take d by dx of this, so that is d by dx of. Okay. So this will be equal to, if you take the differentiation of that, so this will be d by dx of that delta of minus x and differentiation of that minus x. So this will be -1, right? So it will be minus times d by dx of that delta of minus x and delta of x. Because on our right hand side, when you differentiate that x, it is equal to 1 plus 1. So you will get this. Or you can write that minus times delta prime of minus, sorry, what I wrote here? Sorry, ah, that's right. That's right. That's right. Okay. Okay. So delta of minus x will be equal to, so that will be equal to minus delta of. Okay. Okay. Because so this was the, I did a mistake here, because the difference you need to differentiate on both sides. So इसको हमें differentiate करना है both sides से, so you'll get the delta prime of minus x equal to minus delta prime of x. Right? So this was another property of delta function, and we have one more property. That's about if you take the delta of kx plus b. plus minus. So that means I will take first kx plus b, and second case I will take kx minus b, right? So we'll prove that it is equal to 1 by k delta of kx plus b. But we know that we have that delta of kx, so that's equal to 1 by k delta of x. So we have this property. Okay. So let's use this property. So first, let me write this integral. So I can rewrite this. I will calculate area under that curve. So first you write that minus infinity plus infinity, that is f of x, delta of x, right? Right. So let's write this. Okay, now you do substitution that kx plus b equal to some y value. Okay. So you write now that, okay, so what I so kx plus b equal to some y value, or x will be equal to b minus y by k, dx will be equal to minus dy by k. Okay. So simple substitution, you put that kx plus b equal to 1, and x will be this thing, and dx you can calculate. Now use it here because तो limits के साथ में कुछ नहीं कर रहा हूँ, because limit same रह जाएंगे. Because when you put that, if you put that x infinity, so y again tends to infinity. If you take x minus infinity, so in both the cases limits remains same. So our integral will be, so it will be from minus infinity plus infinity. So f of x is, that is b minus y by k, and delta of kx plus b, that's y, and dx equal to minus dy by. Okay, this is equal to 1 by k minus 1 by k, limits from minus. Okay, तो यहाँ पे मैंने क्या किया, simply I take that minus 1 by k out, that is this thing, and rest remains same. So that's f of b minus y by k. Now use that property, so second shift property, because this I can write as delta of y minus 0, right? So before that, okay, so because I can rewrite this as, so this will be equal to minus 1 by k, that is b minus, okay, sorry, there's a mistake. I should write y minus b by k, into, now when you put that y equal to 0 here, so put y equal to 0, so you will get that minus 1 by k f of that minus b by k, limits from, because it is delta of y minus 0, so that's delta y. So this around that curve will be equal to 1. So this will be equal to 1, or this will be equal to that minus 1 by k f of. Okay. Now this I can write as, so this I can write as 1 by k. So you just check minus 1 by k minus infinity plus infinity. That's f of 1 delta of y plus b by k. Because it's very easy. तो जब मैं put यहाँ पे करूँगा y equal to, because b y plus b by k should be equal to 0, or y equal to b minus k minus b by k, because I need to put this is equal to 0, that's y plus b by k equal to 0, और y equal to minus. तो जब मैं b माइनस बी, दिस वाई इक्वल माइनस बी बाई के बराबर होगा, उस टाइम इसका वैल्यू 1 होगा, राइट। तो दैट मीन्स दिस इज सेम थिंग, बिकॉज तो इंस्टेड ऑफ, तो इसके बदले एफ ऑफ माइनस बी बाई के बदले में ये इंटीग्रल लिख रहा हूँ, बिकॉज अगर मैं इस इंटीग्रल को वैल्यू दूंगा तो मुझे देना है y शुड बी इक्वल टू माइनस बी बाई के, राइट। तो जब मैं यहाँ पे y दूंगा माइनस बी बाई के, तो ये बन जाएगा एफ ऑफ, तो ये क्या बन जाएगा, ओके लेट मी राइट दिस इंटीग्रल। तो ये इंटीग्रल क्या बन जाएगा, ये बन जाएगा माइनस 1 बाई के, एंड तो यहाँ पे आएगा एफ ऑफ, बिकॉज y हमारे क्या है, दैट्स माइनस बी बाई के, इंटीग्रल फ्रॉम माइनस इनटू प्लस इंफिनिटी, दैट्स एफ ऑफ y प्लस b बाई के इनटू dy। तो ये जो हमारा एफ ऑफ y प्लस b बाई के है, तो बिकॉज यहाँ पे मैं लिख रहा हूँ जब मेरा y किसके बराबर होगा, माइनस बी बाई के, तो इसका वैल्यू क्या आएगा, इट विल बी इक्वल टू 1, तो ये बन जाएगा माइनस 1 बाई के एफ ऑफ बी माइनस के, वो तो सेम आया। तो दैट मीन्स इंस्टेड ऑफ, तो इसके बदले एफ ऑफ माइनस बी बाई के बदले में ये इंटीग्रल लिख सकता हूँ, बिकॉज पुटिंग दैट y इक्वल माइनस बी बाई के, तो ये मेरी मेरी टर्म 1 बन जाएगी, एंड आई विल गेट एफ ऑफ y के बदले माइनस बी बाई के, सो दैट्स एफ ऑफ माइनस बी बाई, सो दैट मीन आई एम गेटिंग दिस, और क्या राइट दिस एज, so that's minus 1 by k integral from minus infinity to plus infinity, तो इसको मैं अब x भी लिख सकता हूँ, so it is not delta of that x plus b by k d of x, right? So just check, तो यहाँ पे जो हमारा वैल्यू था, so it was okay, so where it was, okay, so this one, this one, तो यहाँ पे जो हमारा इंटीग्रल था, दैट वाज बेसिकली माइनस इनफिनिटी प्लस इनफिनिटी एफ ऑफ एक्स डेल्टा के एक्स प्लस बी डी ऑफ एक्स, तो फॉर के ओके, सो प्लस के प्लस बी, राइट। तो ये हमारा इंटीग्रल था, सो दिस इंटीग्रल, दैट्स इंटीग्रल फ्रॉम माइनस इनफिनिटी प्लस इनफिनिटी एफ ऑफ एक्स डी एक्स, दैट्स इक्वल टू दैट वैल्यू, हाँ। So that will be equal to this one. So that means our limit will be from minus plus infinity kx plus b, right? So when you compare them, so that means after comparing delta of that kx plus b, okay. Sorry, is it minus? So if I am getting it minus or plus? Okay, so let me check it. So is it plus or minus? Okay, so that's minus, huh? Because it's minus here. Okay, x minus b. Oh, that's correct. Because just check it. Well, okay, so when we put that, okay, तो ये वाली टर्म, हाँ, ये वाली टर्म, this one. Okay. So is it minus here? So this is f of what, dy. So dx equal to minus dy by k. That's correct. ये correct है. So that means जो मेरी ये टर्म है, तो सिमिलरली अगर मैं यहाँ पे लिखूंगा डेल्टा ऑफ दैट kx minus b, तो वहाँ पे क्या आएगा, ये आएगा 1 by k that delta of that x minus b by k. Is it okay? Because it's clear. तो यहाँ पे जो हमारा सबस्टिट्यूशन होगा, तो that will be delta of kx minus b, right? तो अगर मैं दूसरा इंटीग्रल लूंगा दैट माइनस इनफिनिटी टू प्लस इनफिनिटी डेल्टा ऑफ एफ ऑफ एक्स delta of that kx minus b x. So you need to check that kx minus b equal to y, x will be equal to b plus y by k, dy by k. That means this will be equal to 1 by k. So just check. So यहाँ पर मैंने क्या किया? I put now kx minus b equal to y and then x equal to b plus y by k, then dx equal to dy by k, and do all these, insert this, all these inside this integral. So ये term बन जाएगा f of b plus y by k delta y and dx हमारा dy by k है. Okay, so let us erase this thing, huh? Because okay, so you can write this as that's 1 by k, that's from minus into plus infinity f of that b plus y by k delta y, right? तो ये टर्म अब मुझे क्या करना है? मुझे अब because this can be written as 1 by k. Now you put at y equal to 0. So at y equal to 0 ये टर्म बन जाएगी f of b by k, huh? So that means I can, because y equal to 0, this will be f of b by k. So ये बन जाएगा 1 by k f of b by k. राइट, तो जस्ट चेक. तो ये जब मैं y 0 लूंगा तो y यहाँ पे 0 बन जाएगा, ये बन जाएगा f of b by k. तो आउटसाइड हमारा 1 by k है एंड दिस इज डेल्टा बाय dy. तो दैट मीन जब मैं y 0 लूंगा उस टाइम पे इस इंटीग्रल का वैल्यू 1 होगा. सो एरिया अंडर दैट कर्व विल बी इक्वल टू 1. सो फ्रॉम द प्रॉपर्टी ऑफ दैट Dirac Delta function. Okay. So what I'm doing? Okay. So that means this integral should be equal to 1. So I can write this as 1 by k f of into 1. और इसको मैं लिख सकता हूँ. Let us write this in terms of that delta function. I can write this as 1 by k, that limit from minus this plus infinity, that is f of that y लिख सकता हूँ ना इसको ऐसे, because y equal to b by k. तो ये टर्म अगेन एंड यहाँ पे f of y by k, तो ये टर्म बन जाएगी. तो यहाँ पे जो इस इंटीग्रल का वैल्यू होगा जस्ट लाइक इन अर्लियर केस, तो इस इंटीग्रल का वैल्यू वहाँ पे 1 होगा, बिकॉज व्हेन यू पुट दैट y इक्वल टू b by k, so you should have this area under that curve is equal to 1. So the value of this integral will be equal to 1. So this is, so that means इस फंक्शन को मैं इस फंक्शन में लिख सकता हूँ, right? Now instead of that x, if you choose that instead of x, I can write in terms of y, right? Because I can write this as 1 by k, that so that's equal to, that's this thing, because this was f of x kx minus b, so this is kx minus b, f of x kx minus b, that's equal to this thing. तो अगर इसको मैं कंपेयर करूंगा तो दैट मीन हमारा जो kx minus b होगा, so that's equal to 1 by k delta of that x minus b upon, right? So that means हमने both केस लिया, that means when it was that delta of kx plus b, तो वहाँ पे -1 by k आया था, and that integral that's equal to 1, sorry, and that -1 by k delta of that x plus b by k, अगर मैं यहाँ पे kx minus b होगा, यहाँ पे आएगा 1 plus k. So that means first cases में -1 by k आया था, अब यहाँ second case में हमारा +1 by k. So that means I can write instead of that mod of that 1 divided by mod of k. So that means I can write this as this integral from that okay. Okay, so x plus b by k. Okay. Now the last property. So there are so many properties. We can also do the Fourier transform or of this Dirac Delta function. So I will not discuss that in our today's lecture. So maybe next time we will discuss about if we take the Fourier transform of these Dirac Delta functions, and if we take some Gaussian functions, we can say that Gaussian functions behave like Dirac Delta function under certain conditions. Maybe hopefully we will discuss that in our coming lecture. Now another property is that if you take now the last property, that is if you take x with d by dx of that delta x, so that is equal to minus delta of x, right? So that means इसका वैल्यू किसके बराबर आता है, that's equal to minus delta of x. So if we take left hand side, take LHS, so this is basically, and integrate that x d by dx of that delta of x. Okay, because I need to prove that x into differentiation of that delta function, that should be equal to minus delta of x. So I will integrate this, I will calculate that area onto that curve. So that will be equal to take the differential part and this integral part and use that, integrate this equation, this integral. So this will be u integration of v, so that will be u, sorry. Okay, so x delta of x from minus infinity to plus infinity. Now we take differentiation of that x, that's equal to 1, and integration of that d by dx of delta x, that is delta of x. Right? When you take its limits, because you are getting, so this should be equal to 0, right? And this will be equal to that minus into plus infinity. Now using the first property of the delta function, so this should be equal to 1, right? Or sorry, because we need to calculate that, so this is equal to minus into plus infinity, x d by dx of that delta of x. So that means जो इसका वैल्यू, इस इंटीग्रल का वैल्यू आया, that's minus into plus infinity x d by dx of this thing, that's equal to c. So that means if you compare that, so that means x d by dx of delta x equal to minus delta of x. So on comparing, x, so there are some more properties, hopefully if possible. So in our coming lecture I will discuss some of the properties, and even if we talk about the Fourier transform, delta function and Fourier transform, and some more properties of this delta function, hopefully we will discuss in our coming lecture. Thank you very much.